Hello, 7th graders, Mix there here. Welcome to lesson 3.8, where we will be looking at situations and deciding if it is proportional or not. Your learning target today is I can identify the proportional relationship from a word problem, and I can use evidence to justify my thinking. So in the situation we're going to look at today, we're looking at GrubDash, a food delivery app that is offering two different options for users. Our first option, which is our regular user membership. So this is members can get free use of the app, but a delivery charge of $3.99 will be added to each order. Okay, and in the Super Snacker membership, woo! After a $10 monthly fee, the delivery charge drops to 99 cents per order. All right, so what I would like you all to do is, and let's do this one for our regular membership and then this one for the Super Snacker. Go ahead and get those Y values filled in for 0, 1, 3, and 10. All right, here's what I got from mine. Go ahead and make sure that your tables and your notes match these, and then we'll get to graphing. Okay, so again, to graph, we're going to take our x's and our y's and turn them into coordinate points, x, comma, y. Now, I want you to get your graph set up in your notes, so that means make sure that your axes have labels. So your x-axis is the number of orders, your y-axis is the total fees, and for your scale on those axes, I recommend using a scale of 1 for your number of orders. And then because our data points are moving somewhat in groups of 4 right here, I went ahead and scaled my y-axis in whole 4s, and then we're just going to have to be doing some estimating. Okay, there's my coordinate points for my blue group, which is the regular membership. I'm going to go ahead and put a line through those. Then I'll plot my Super Snacker membership points, starting with that 0 point. So here where x equals 0, y actually equals 10. So there's that. I'll get the rest of those plotted. Okay, there are those. And again, this is just kind of a rough estimation. Go ahead and put my line through it. Okay, now that we have everything graphed and we have everything in our tables, we can go ahead and start looking at some of our evidence and deciding which of these relationships is proportional and which isn't, and explain why. And in all the lessons prior, we have found so many pieces of evidence that we can use for this. I want to start with looking at the tables. From a table, we can decide if a relationship is or is not proportional in a couple of ways. And the easiest of those is, of course, to calculate our k for each table. If k equals y divided by x, are these relationships proportional, meaning do they have the same k? Go ahead and pause and calculate your k's for these. So our first piece of evidence will show us very clearly that this regular membership, because all of the k's are consistent, is in fact proportional, and the Super Snacker relationship, because they all have different k's, is not proportional. Now there is another thing we can look at on these tables to identify a proportional relationship. And that is, in a proportional relationship, when x increases in value, let me go ahead and highlight that, sorry. If x increases in value, the corresponding y must increase in value equally. In other words, if our x doubles, then y has to double. If our x triples, then y has to triple. And let me show you what this looks like in our tables. So we've already decided that this one is proportional and this one is not proportional. And let's look what happens when x goes from 1 to 3. That is like saying we took our x and we multiplied it by 3. That would mean that because this is proportional, we would need to see that exact same thing here. We would need to see that $3.99 times 3. And if we do that calculation, indeed, that is true. So when our x multiplied by 3, our y multiplied by 3. And we can look at that in the non-proportional. Here what happens when x multiplied by 3, our y did not multiply by 3, right? 1099 times 3 would equal 3297, which is not what 1297 is. So there's another piece of evidence that this is not a proportional relationship. It means our x's and y's are not changing or increasing or decreasing at the same rate. Graphs can also give us this really quick and easy answers to whether or not something is proportional. Let's remember the 3 things that have to be true for any proportional relationship on a graph. And that is that it must be linear, both of these are. It must pass through the origin, one of these does. And when x equals 1, your y is going to be that k, the constant of proportionality at that point. So right here, our piece of evidence of which is or is not proportional is that this super saver, when x is 0, y was 1099, which right away means that this is not going to be a proportional relationship because it does not pass through the origin. And also, since we already calculated in the table that our super snacker does not have a k, that means that this point right here, where x is 1, is not a unit rate for the situation. Whereas for our regular membership, both of those things are true. Passes through the origin, and that point where x is 1 was that 399, which we decided was our k. So we have that point right there of 1, 399, where k equals 399. And lastly, what is some evidence we can start to look at from a word problem just to decide whether or not right away something is proportional? And for these, one of the best things to look at is look for a starting point. Meaning, where's our data going to start? Or when x is 0, what is our y? That will give us some really excellent information. As we read through our regular membership, which we now know is proportional, we see that before this person has ordered any order, they have not spent any money. They had free use of the app, which means that for 0 orders, they've spent $0. Whereas for our super snacker, before they have ordered anything, they've already spent a $10 monthly fee. So for them, 0 orders, $10. And that automatically means that this cannot be a proportional situation because that starting point for the super snacker is not 0. It is when x equals 0, y equals 10. Therefore, it will not go through the origin of our graph. And it will just mean that there will be no consistent k. So again, from just a word problem, you can look at starting points to start to gather some of this evidence. All right, go ahead and work on those journal problems. Let us know if you need any help, and good luck.